Good morning, KubeCologne.
Good morning.
Whoa. Someone being out yesterday, huh? All right, my name is Michael. I work at IBM, Red Hat, and this is really a topic I really think it's super important that we all have a good handle on that. Quick show of hands, who is using Kubernetes in production? Okay, so that's a third, a little more than a third. And who is toying around with Kubernetes, trying to get into it? Okay, and the rest is here for the nice view and nice people. Okay, cool. So the scope is focusing on the prototyping, developing, and testing of applications. So not really about, here I'm going to set up a cluster and how to troubleshoot that, or performance testing, optimizing microservice, what is SRE style troubleshooting. That's out of scope. I'm really focusing on you as a developer, app ops, DevOps, whatever, you're developing application, deploying that, and trying to figure out what are the things that can go wrong and how can you mitigate them or address them. So let's have a look at what we're really dealing with, and that is a distributed system. If you think back of Monolith, you have a version 1, and 6 months later, if you're lucky, you have a version 2. With Kubernetes, if you're actually all in, if you're really writing microservices, it looks more like that. You have a couple of microservices in different versions, and, every day, every hour, whatever, you churn out new versions. What is important here to note is that now, unlike in the case of the monolith, where you have an exact place where to point to and say, here is the culprit, here is the problem, with microservices, you don't. You simply don't know where to look, where to figure out what's going wrong. So this is the overall setup here. And remember, you're really just treating the one for the other. It's not that you're getting something way better or easier. It's just you have one set of problems and you exchanged it for another set of problems. From a purely logical point of view, it looks very nice and clean, right? You have your cluster, you have your namespaces, and then you have apps that typically are composed out of containers in pods, persistent volumes, services, deployments, stateful sets, and so on. In reality, unfortunately, it looks a little bit more complex. You have a lot of moving parts. If you're lucky, someone else takes care of the control plane, but still, there are many moving parts on the worker nodes you have to probably be aware of. You can't just pretend they're not there. You probably need to know what these things are doing, a couple of specifications there, supervisors, and so on and so forth. All right, so what I did in the research part was essentially I was trawling one of the beloved Q&A sites. No, it's not Reddit, it's Stack Overflow. Put together the super academic and scientific top 10 failures that I found on Stack Overflow. Invalid YAML specifications. We're all YAML engineers as Kubernetes practitioners, so that's probably one of the nicest one that you find. Wrong or missing permissions, wrong container image. Don't worry, we're going to go into greater detail in a moment. And there is a failure to access the container registry, a supposedly long-running application that just exits, missing and or bad configuration or secret, lifecycle issues, liveness probes or readiness probes are failing, can't reach the service, I can't get to the service within or from the outside of the cluster. And what actually is localhost? Very often you find that confused there. And failed mounts, I can't mount this or that volume into my container. All right, what is important and what I learned when I'm trying to reproduce things from Stack Overflow to actually come up with an answer is that you're not just poking around, just trying your luck, but have a structured way to go about that. So meet the OODA loop. OODA essentially has a military background, essentially the idea of you observe, establish a baseline, look around what's going on. You orient yourself by formulating hypotheses. Don't jump to a conclusion at this point in time. Don't say, oh, that's the one I'm going for. But sort these hypotheses by likelihood, saying, yeah, based on what I've observed, it's very unlikely that it's this. I'm going to start with this one over here, and then test it. If it's the one, great, you're done. If not, next round there. So let's have a look at how that actually looks like in a concrete setup. Prepared a little deployment there, and if your YAML is as good as it's supposed to be, then you can probably guess what it is doing, and maybe already have an idea what's going wrong. But let's have a look and apply the OODA loop step by step. So in the back, can you see that? Yep, okay. So let's apply this little thing here. So that's the YAML I just showed you, and looking at the pods, we will see, yeah, completed. Okay, crash back off. Oh my God, what's going on? First step, observe. Have a look at stuff, right? So let's have a look at the deployment. Describe, deploy unhappy camper, if that was the right one. That's why I have it prepared. Yeah, dash, of course. That was not part of the demo. Okay, looks all good. The only thing I can see here is one is unavailable. Okay, so deployment itself seems to have some kind of issue. So let's have a look at the pod, and I just have an environment variable here that essentially captures the one pod. We only have one replica in there, so I can use that to look at the pod itself. So let's describe the pod. Where are we here? Okay, let's have a look at the pod itself. Okay, has been scheduled, image has been pulled successfully, created a container, but then some things happen. So it's towards the end of that life cycle there. Okay, cool. Let's see if we can get into the logs. Is there actually an output from the container itself? And oh yeah, there is some output. So apparently it was scheduled, image was pulled, everything is fine, and I actually see the logs, but that's it. Okay, so what's next? So that's just a fallback in case the network wouldn't work. Okay, so observation, deployment seems okay, pod seems okay, I see log output, but it keeps crashing after launch. So what are my hypotheses? Could be a resource issue, could be some ooming or whatever, could be some missing configuration and data. And although I don't have that in the YAML file, it could be some default on the namespace. So yeah, could potentially be. Or it could be something in the application logic itself, some runtime error there. So now we're going to sort that. And based on my experience, I'm going to start with that application logic error. Could still be a resource issue. Again, could be some quota, whatever, by default in the namespace. But I'm starting with that, and I'm excluding that configuration data missing. Yeah, I know that there is nothing else there that it depends on, so that's the number one. So I'm starting with the application logic runtime error. So let me try something out, and this is the specific part that obviously depends on your application. Here I'm just going ahead and do something very silly, but this would be the point in time where you probably would debug it or whatever to figure out what's going on in that application. Just editing the YAML file here, the deployment file, and this would be the part where I would actually say, I fixed the application, right? Okay. Oops. That's fine. Okay. So let's see if that has helped anything. And yay, it's running, right? So I fixed it. Okay, of course that was cheating, sure, but you get the idea. After having verified what could be potentially going wrong, I'm testing the first hypotheses, and by changing something in the code, in this case, yeah, very simple, I fixed it. Great. Okay, so what we've seen so far was things like, we haven't really seen get events, but things like the built-in things like describe and exec if you have to get into the container at some point in time, logs, or you could use kubectl or stern for more sophisticated things, getting logs from different containers together. Or what I would recommend, at least in addition to these basic built-in commands, a kind of full-blown observability approach. So what is observability? In the context of microservices, we're thinking on 3 layers here: the metrics, the logs, and distributed tracing. Metrics could be on the node, mainly relevant for infrastructure admins, container runtime somewhere in between, and app level. Get all of that together through an event router. You have guessed it, it's Prometheus, and then you can dashboard it or alerting on certain things or put it in long-term storage and having a look at trends or whatever. You get the out-of-the-box low-level metrics, CPU, memory for free. For the application-specific ones, you have to decide, is it a full-blown instrumentation in-tree, or are you using service mesh-based approaches that have a lightweight footprint in terms of instrumentation. You can roll your own. If you do that, if you're on premises, I want full control, definitely use Prometheus and or Grafana together, or the cloud provider native ones. Have a look at, OpenShift has some quite nice high-level integrations there. Grafana, service meshes, in this case Linkerd, giving you some insight what's going on between services. And pretty much the same is also true for logs. So the only thing there you have to remember, don't log into a file, always log to stood-out so that Kubernetes can pick it up and you can aggregate it easily. And again, you can roll your own ELK, EFK stack, or use the cloud provider native one, depending on if you are in the public cloud and can use that or not. And again, EFK or Kibana really, quite widely used and appreciated. Moving on to distributed tracing and debugging. The problem there again is you don't really know where in your overall setup something goes wrong, and it's not really easy to, because there are different nodes where containers or pods might be running, to figure out how to align them based on their time stamps. So what you're doing essentially is with distributed tracing, when a request comes in the request path, you assign an ID, and each of the services passes that request ID further on, and then you have a system and specifications like open sensors and open tracing that allow you to stitch that together and get an overview in a waterfall model where you can drill down. A lot of tooling that support one or two of these specifications, and I would argue that in a microservices setup, which we have, if we're doing it properly, it's a must-have, so you should definitely have a look at that. There's also support for debugging, things like kubesquash that actually allow you to live debug a application that is deployed in Kubernetes. I'm not going to go into greater detail there. Just a few screenshots that you get an idea how that actually looks like. You have this waterfall model request path, so one service calling the other, and you can at a glance see exactly how long it takes in which service, and you can drill down and have a look at the logs of the respective service to figure out what's going on. Again, in our setup, I would say it's a must-have. All right, switching gears. Our apps run in pods, or better say containers in pods, and these pods sometimes fail. If you remember back the top 10 list. Before we get into that, just a quick reminder, what is actually in a pod? A pod contains one or more main containers, so these are typically the long-running things, one or more init containers, where the guarantee is that the main containers will only be launched once the one or more init containers have completed. Typically used for either synchronizing things, so you say I can only start if that other service is up, or to create some initial data, so pull some data from somewhere else, set up a database table or whatever. And then you have the liveness probes kicking in, liveness and readiness probes. Liveness probes for kubectl, the kubelet to decide to restart a container, and the readiness probes for services and deployments to decide if a deployment is fine or a service can route traffic to a certain endpoint represented by container. So I've put together, to structure that a little bit, end-to-end, what is going on if you're doing a kubectl apply, what I did initially there with a certain manifest, what is going on in terms of in the control plane up to the worker node until the pod eventually gets destroyed. So let's have a look at the control plane. Already mentioned early on, you might be laughing, but that happens quite often, that some indentation error or whatever typically should be validated, and kubectl should be able to tell you, but sometimes it's a little bit more subtle. But make sure that you have, there is IDE support and so on. That shouldn't be a big problem nowadays, but still happens. Once you say kubectl apply, you might see something like, kubectl says you're not allowed to do that, right? There might be things that are actually outside of your control, direct control, so you might need to interact with some namespace administrator or infrastructure administrator there. But quite often turns out, yeah, you've neglected some RBAC rule or whatever. Quick reminder for you to appreciate what's going on. First step is the authentication. If you see some 401, you know that something in the authentication is gone wrong, right? It might be, if you're in a cloud setup, it might be provided via a webhook, so you might need to dig into some IAM or whatever. You might be using X509 client certs. But if you see 401, you know you don't need to bother with RBAC rules, whatever. You know some kind of authentication issue. Going on with 403, it means something nowadays typically RBAC, so probably some role not well defined or a cluster role binding missing or whatever. You can very easily check that. kubectl auth can I. You can also impersonate. You can say with that user, is that user allowed to list pods or create deployments or whatever. Do make yourself familiar, even as an app ops, with pod security policies and network policies. Again, that might very often be something that's outside of your control. Network and namespace or infra admin might actually set up these policies cluster-wide or namespace-wide, but they affect you, right? It might work in your Minikube setup because you haven't defined a network policy, but then in staging, prod or whatever, you might have certain network policies saying that, you know, in this namespace, pods are allowed to talk to this other namespace, but not the other way around, for example. So you need to be at least aware of those. Liz Rice from Aqua and myself have put together a book and website called communitysecurity.info. A lot of material there if you want to dig deeper there concerning anything security really. All right, that last step in the control plane, and while I've kind of tongue-in-cheek said fork out more money, sometimes it's not really that. Sometimes it's really as simple as some affinity. So someone trying to schedule something on the master and that's not allowed. So make sure that you understand what kind of scheduling is allowed and look at the events. Has the pod actually been scheduled on the right node, for example? All right, moving on to the worker node. A lot of things going on there, and again, not everything that you as an application developer can directly change or fix yourself. Especially around the container runtime, if you have an issue there, you very often need to ask your cluster admin. But the number one thing that comes as soon as the kubelet tries to pull or instructs the container runtime to pull the image is access to the registry. Might have a lot of reasons. You might be using a private registry. There might be some issues in your setup. Very often that happens when you go like, oh, due to whatever reason it doesn't come up. You need to check. Can do a Docker pull or whatever to check manually if from that node that image can actually be pulled. Then wrong image. And again, you would think this is very simple to figure, but sometimes it's again quite subtle. The general underlying expectation of Kubernetes is that the tags there, the images are immutable, whereas Docker in itself allows immutable tags. So you kind of like need to figure how to manage that impedance between these two systems. And it could be something simple as, I didn't specify anything, so I get latest, and someone has explicitly moved that or whatever. Very, very annoying to figure out. And kubectl get events is your friend there. I've linked to this troubleshooting.kubernetes.sh site that has some more examples there that you can reproduce and see what's going on, and links to some more Stack Overflow issues. There are a couple of startup issues that you can experience around init containers. I haven't really found a good example on Stack Overflow, but very often around the semantics. So remember, init containers, it means it first executes that. If that executes and exits with a 0, says, all good, I'm going to start the main containers, you might see something there that is unexpected. This is the one that we've seen in the beginning when we talked about the OODA loop, that, again, think of what abstractions, the supervised abstractions, in this case, the deployment, what it assumes about your workload. Deployment assumes a long-running application, which means a while loop. If your application exits, thinks, oh, something's wrong, I need to restart it, right? So these kind of using certain abstractions, be sure that you understand the semantics of a job, of a stateful set, of a deployment, and so on. Yeah, and that's typically what you use, describe, exec into the container. Make sure that if you do that, if you're actually executing into the container, which is the equivalent of SSHing into a node, that you first take that pod outside of the deployment. Just remove the label or whatever, take it outside of the deployment. Deployment will create a new pod, and then you can debug it while everything is still preserved. If you're lucky enough, you even might get logs, so you know that your application is some kind of in a running state, but might crash after that. That's what we had early on as well. Moving on to networking. So in a sense, networking really boils down to three things. Stuff that happens within a pod, that's everything localhost. So each of the containers within the pod see each other on localhost. That's what the pod actually is for, right? It was modeled after like a machine, like a VM, that you easily can deploy multiple applications there that see each other on localhost. In this context, things like, for example, port management that you need to do yourself might be a stumblestone. Then you have east-west traffic, so one pod talking in one namespace with some other pod, typically through services, providing a stable virtual IP. You might have these inter-pod networking issues there, and then you have north-south traffic, ingress and egress that might cause issues. All right, so one of my favorite ones is this localhost issue. What does localhost really mean? So if you have hard-coded in there 127.001, that will cause you issues, right? Because the basic idea of a pod is it gets a unique IP every time it comes up in the cluster, which is routable within the cluster, and that is almost never 127.001. So if you have to, if you see that kind of issue, you probably want to check on what network interface your application is actually listening, and you're on the safe side with 0000. Wrong port, again, think of or consider the fact that within the pod, the port management is up to you. You need to make sure that your containers are listening on different pods, or your applications in the containers are listening in different pods. And sometimes it's a bit unclear if you have deployment and service, what is the actual port that a container application is actually serving on. The what and the how. So make sure you understand the CNI, pretty stable at this point in time. You have to make sure that you understand, is it an infrastructure issue? So, on the CNI level, some plugin missing or misbehaving. DNS, always a good starting point. Or is it something in your application, as I mentioned, listening on the wrong network interface, port issues, or whatever. And again, there is a website that talks about this container networking, Kubernetes networking, lists a lot of references there. Moving on to stateful apps. How are we doing time-wise? I think I'm still good. So theoretically, Kubernetes is awesome. No, practically, Kubernetes is awesome, but theoretically, the stateful apps are rather simple. And that is a separation of concerns between the network and infrastructure admin and the developer. So nowadays, you would typically use dynamic provisioning. You would define, or admin would define one or more storage classes, and based on these storage classes, Kubernetes would automatically create persistent volumes. So you would say slow and fast. Slow would be HDD backed, and fast would be SSD backed. And then as a developer, you have a persistent volume claim. You want to use one of these persistent volumes, and then Kubernetes would automatically create this persistent volume based on the storage class, and then bind it, and you can mount it then in your container as a volume. Often the docs actually spell it out or have links that give you the background on what you can expect from that. A bit more annoying are things like that. So for example, in the setup, if you have a stateful set and you have a persistent volume claim, in this case, a gentleman here requested 64 megabyte. Can you guess what the issue is? The minimum allocation is 20 gigs. So, and again, you could just say, read the docs, but it's, you're at that level where you look at that, that's, it's syntactically valid, it's all fine, but the volume doesn't come up, right? So really make sure that you understand what your provider in the cloud or on premises does for you. Oh, sorry, I'm distracting you. Understand what the offering really is about, minimum, maximum, and so on and so forth. Understand the failure mode. And again, we have a web site, Stateful Kubernetes SH, that lists a number of these issues, further material, and so on and so forth. One point which you might be, and luckily in Europe this is not as contentious as when I talk about these things in the US, for example, and that is vaccination. And to be honest, this is something that before things happen you can really, or should be investing a lot. So let's have a little quizzy time, even if you're not that familiar with Kubernetes, might be good to participate. So imagine you wrote an application server, and for load balancing purposes within the cluster, where would you put a reverse proxy such as Nginx? Into the container, so in the same Docker file, into a Sidecar container in the same pod, or into a separate pod? Who is for A? Don't be shy. Well, okay, oops. Who is for B? Okay, one brave, two brave. Who is for C? Trick question. Don't use it. Use services. That's the point. So that's point number one. Understand the Kubernetes primitives, right? A service is meant, besides providing a virtual stable IP, so pods that come and go and have different IPs, don't disrupt the DNS setup. It serves this purpose of a load balancer. You do not need to deploy that in addition. You just use a service that load balances between the pods, right? So make sure that you understand the Kubernetes primitives, where they come from, what their semantics are, and then a lot of things get easier. Do not, or try not to implement hard-code dependencies, and always implement retries and timeout. In tree essentially meaning some kind of library, Hystrix or whatever, or via service mesh, ideally. Again, introduces another level of complication there, but from a certain number of services on, definitely recommendable. All right, we had that, and again, just a reminder, localhost is not always what it seems to be. If you can, if you're brave enough, not necessarily in prod, apply chaos engineering so that you learn how your system works as long as things look good. Think of how minimal you want to have your container image. You might, at some point in time, get into a situation where you don't have anything there to actually look around. And automate all the things. There's a raft of tools that you can use to automate your workflow, and definitely have a look at one or more of these things. Makes your life easier. All right, the rest is a couple of resources. Some of these books are actually here, as we've learned earlier on, and a couple of materials, slide decks, videos, and so on that you might find interesting. And with that, if we still have a minute or two for Q&A? 15 minutes. 15, awesome. All right, so with that, we open Q&A. If we have a microphone. Okay. So you might need to come up front if you're brave enough. Don't worry. Who is the icebreaker? Who will ask the first question? No? No questions? You just gave up on Kubernetes. It's too complex. No? Don't worry. If you have a question, I'll be around. And just hit me up. Oh, there's a question. Yeah.
You talk about sidecars within the pods, but I'm not sure how to figure out which is the problem when the sidecar is crashing. Because normally you would see the main
No. So the question is how to figure out if a sidecar container is crashing. And the thing is, maybe it is a little misleading here. When I say main container, I don't mean that there is one container that is, more important than the other. Initially we didn't have init containers. It was just a bunch of containers that would run in that pod. So they would all run in parallel. If you have, let's take an example like a service mesh like Istio, where you can inject another, in this case Envoy as a sidecar, that takes over essentially the network management for you. Both are main containers, right? Both are, from my perspective here, they're the main containers running in that pod. They might, have, in terms of, for example, Envoy, different priorities or whatever in terms of network management, but they're both main containers. Main in contrast to the init containers that essentially, initially, that the guarantees they will first be executed before one or more of the actual containers are executed. So you just need to check, is there an init container or one or more init containers? Yes. So you need to see, are they actually executing, or are they, maybe there is a bug that they are running too long or in an endless loop. And then once the one or more main containers, for each of the main containers the same is true, right? You could have a post-start hook and a pre-stop hook, and then at some point in time the liveness probes and readiness probes kick in. So from that perspective, all of them, the sidecar container is not, second-class citizen or whatever, it's the same, right? The same principles apply. Sometimes a bit tricky to figure out what interdependencies there are, but yeah, the only thing to remember, init containers are guaranteed to execute before the main containers. Once they are done in a successful way, then the main containers are executed. Any more questions? No?
Right, so you talked mostly about attack problems that people are introducing by users.
Yeah.
We had some failures because of Kubernetes internals, a lot of stuff that I would be able to look at, but how would you approach that? Where to go, what to do first, what is your idea?
So basically, at least in terms of anything that runs a workload, effectively creates pods. This is more or less, yes, it glosses over a few things, but this is more or less what is happening, right? You have certain things that are going on in the control plane, certain things that are going on the worker node. The events, the get events is actually quite powerful. It might be a lot to filter it down to what you need, but that is essentially where you get, okay, what is going on? All of these, that is essentially how Kubernetes works, right? Right. So in the control plane, you have that controller manager that implements a number of these controllers, deployment, replica sets, and so on and so forth. And all of them essentially just listening at the API server at certain endpoints saying, oh, I see, for example, an event that a pod has been created or deployment has been created and so on. So at this point in time, the get events can actually tell you where in the control plane something is going wrong. You might not have access to the control plane itself. So if there is something like, managed offerings in public cloud provider environments where you just don't get to the control plane, yeah, you probably need to raise an issue with your provider there. So you can't, change things on the API server. You can't say, oh, I'm going to restart the API server with some other flags. That's outside of your control. But if you run it yourself, if you run the control plane, then that's something you could also give it a try, right? It's like, oh, maybe in terms of, I don't know, the wrong authorization module or authentication module is enabled or not enabled or whatever. But if you look at Kubernetes as this event processing thing that only reacts, all of these controllers and so on, all of them just react to the events that are happening there, then that's a really good start. The reason why I've separated is that what is going on the worker nodes itself with all these things here, the kubelet and container runtime and so on and so forth, that's a whole different set of problems that very often the application developer needs to work together with the infrastructure admin. So it's like, oh, I'm seeing that issue here, could be something with the CNI plugin you're using, right? So in a sense, this is real DevOps, right? You really need to work together to resolve these things. And the main message here is, as an application developer in this context, you can't just say, here's my application, run it for me. Unlike in a PaaS environment or serverless environment where you don't really need to take care of these things. You need to be aware of them and need to have a kind of structured approach to that. And I hope I've shown you some of these tools that allow you to do that. But yeah, it's not easy, definitely. Yes, in the back. Yeah, if you can speak up.
I was wondering, with Etsy being the only store that's somewhat of opinionated approach, do you believe that
So the question is essentially if etcd as an opinionated one implementation piece will change, or
that was one example of
yeah.
there has been one decision has been made to simply choose one implementation.
Right.
Go the opinionated path versus
Okay.
fully abstraction and make Kubernetes like more flexible, but in a sense more compact.
I would actually argue that we already see that with etcd. You have both Azure and I think Google as well have essentially implemented different backends, so they're not running etcd themselves, it's just the etcd API. So I would probably guess that the etcd API itself becoming whatever you want to call it then, container native state storage, whatever interface. But that's the whole point, and yes, so I would agree that you would probably see that everywhere, and that's actually one of the strong points of Kubernetes, that the APIs themselves are standardized, and you can essentially implement it the way you like. Are you suggesting that if you're using like a Kubernetes distribution, something that takes vanilla core Kubernetes and does something for you, makes it easier to install it, adds some pass level like OpenShift or whatever, that it's harder to debug, or I'm not entirely sure if I'm following.
Well, here we are talking about the issues that normally are raised or caused by application developers or the DevOps people, but there is a meta level where we have a higher landscape level where Kubernetes is only one of the players
Right.
in the landscape. There
Right.
are management consoles like Rangers and the other things, and for example, Ranger prerequisite very specific version of Kubernetes
Right.
API to work with.
Right.
And we know that all these products are evolving very fast,
Right.
very rapidly.
Right.
And you cannot keep going with changes. So once you upgrade your Kubernetes, you have the risk that your Ranger doesn't accept that version. So and so on. So and there are many players on the landscape.
Right, right. So I would argue there are two levels that you can look at that. On the one hand, if you have higher level abstractions, if you take a pass like, whatever OpenShift or others introduced there, where you're trying to abstract certain things and maybe don't expose low-level things like pods or services or whatever to application developers. Just say, take my application like Heroku style, deploy it. Right? I would still argue that certain things shine through, because at some point in time they will see something pod related or service related. So you still need to have that knowledge down there. In terms of fast moving, yes, that's true. Right? We still have every couple of months a new release. But I would argue that this, to me at least, is an opportunity to essentially try out new stuff. I would not recommend to always upgrade your cluster to the latest version, but you might have, I don't know, 3 or 4 more clusters where 1 or 2 of them are for prod and staging, and one of them where you actually, on the one hand, go through the exercise of upgrading it and also figuring out what a new interface or whatever, how that behaves. So in this case, yes, it is a pain with this fast-moving ecosystem, but as long as you're kind of sensible in terms of what you're deploying into production, I don't see that as a huge issue. It's manageable. But with the abstractions, yeah, that's something. I don't think that anyone has found a really great way to go about it yet. It's still very much
Would be a
evolving.
recipe to, let's say, not directly migrate your cluster, but create a copy of your cluster with the new version and see if working fit, and then actually switch.
Yeah, that could be it.
Thanks.
Yes.
What's your preferred way of debugging microservices in the cluster? Running on local nodes, looking at remote debugger, or
Right. Right. So the question was how to debug, and for that, like two steps or 2 phases. The one is actually figuring out which one of the microservices / containers, pods, whatever, is actually misbehaving. And that is, if you have a non-trivial amount of those, you might have 20 or 30, your only really chance is to distributed tracing, essentially to figure out okay, this one, I expect it runs for 100 milliseconds, it runs 500 milliseconds, so I'm going to start here to figure out where in your setup you actually have the problem. At that point in time, there are open source things like KubeSquash, and public cloud providers have their own proprietary ways where you can actually set a breakpoint, essentially say, okay, I'm going to go in there and actually live debug it. Related to that is sometimes this kind of testing. So if you imagine you have, let's say, 10 microservices. So that might be physically 10 images, 10 pods that you're deploying, and you're developing that one thing here. So your problem is you might be, working locally on that one, but all the others are, other teams, they're already running whatever. So then you have a couple of options. You can either use proxy things like telepresence to get these others onto your machine so that you can actually go through the entire request path, or you reproduce them locally. So you essentially run all of them locally, which sometimes might be a bit too much if you have big system, distributed system that takes a lot of memory. So proxying might be sometimes your only chance. And the other question is then in terms of velocity, because if you think about the entire workflow, right? You change something, you create a new image, you push it to the registry, you wait until the deployment has kicked off, pulled kubelet pulled it from the registry and deploys it. That might be 5 minutes or whatever. You probably don't want that, right? You would want something. That's why I mentioned a number of these tools like Scaffold and others that allow you to shortcut one or more of these steps, that you can essentially you save it, and a couple of seconds later, you have essentially a new pod there, either by replacing what is going on there, or there are different ways to go about that. But proxying is certainly something, and the rest, the debugging, I would argue it's still early days. It's not awesome in terms of integration and so on and so forth, but it's there. You can do it. But the bigger issue really in non-trivial systems is really to figure out where to start, and that's where distributed tracing is essentially, that's why I said it's really a must-have. I think we have time for one more question. Yes?
So from your experience in the last years working with Kubernetes and writing groups and so on, what's in your eye? Kubernetes has a lot of pain points, right? So what is the most hard pain point of Kubernetes in your eyes? So what shall we take her at the first step?
So so the question is, what's the hardest or the most painful one? And to me, it's an analogy with Go holds there, and that is, I've been using a lot of different programming languages, C++ and Java and Python and Node.js and even PHP. I was young and needed the money. No, PHP is cool. And the hardest thing for me learning Go a couple of years ago was essentially to forget about all of that, right? Just to say, okay, this is the way it's done, and I'm just going to learn it that way. And that's what I see very often with, just something's called deployment or service. You might have some idea in your head from your previous experience, and you're trying to force that idea on those abstractions. And that's the wrong way, right? If you can let go, if you can kind of unlearn, doesn't mean that you have to throw everything away, but really have a look at what do these abstractions really do. Some of them don't really do a lot, right? And most of these are, if you ask ops folks, that's what they've been doing for 10, 20 years, right? It's not something that has been, just created or newly invented there. It's just that it has been standardized, right? This is what a deployment looks like. These are the semantics. If you can essentially forget what you know about, these things, and just have a look at what they're really doing, what they're really abstracting away, what they're doing for you, then a lot of those issues go away. Very often, that's the number one thing I found is like, okay, boils down to, did you actually read the documentation, what it actually says, right? And sometimes, you can't really blame people because there's a lot of docs there, and the docs perfectly tell you what to do, but they don't really give you the background. They don't tell you, look, that's the way, that is the reason why it is modeled that way, right? They just tell you, this is how it works, this is how you go about that. And the back end is like, what's the underlying motivation for it? Why is it done that way? Is very often missing. That's what we can do as a community better. We can explain why does a pod look like a pod or a deployment like a deployment. Okay, All right, thank you very much.